Hello everybody, my name is Mewael Ahmedin and this is going to be my video for the FEA final report. I had a report on the English Warbow, which I have modeled up here in SolidWorks. And we will now take this from SolidWorks to Abacus. Way we go about that is just going export and then saving it as a step file here. Save it to some area that you know where it is. Hit export. And then I will show you how to do this on the school computers over the internet here. This is a website for the school computers. If you go here into the enhanced computer, you will have that. Send that step file to yourself and we will begin. All right, so on the school computer here, you will want to have downloaded your step file right here. And you can now just hit start and open Abacus. All right, so once Abacus has started, you will select standard explicit model, and then you'll import it, which you'll do file, import, and then parts, and then change the file type to step, and here it is. So boom, we'll import it just like that. Sometimes it'll come up with an error that says there's some highlighted imprecise geometry. Just ignore that for now. We're going to be doing a static deflection model on this bow. So every bow will need its string. And if you see here that you can't kind of maneuver everything as you would in SolidWorks, what you can do is go to Tools, Options, View Manipulation, and move it to SolidWorks. Hit OK. So now we can maneuver it with the center scroll wheel. But this is good. We have our Warbow. So next we'll need to make a string. We'll call this string. It'll be a 3D wire planar. It's going to need a large amount of space, so we're going to change that to 2000. We're going to have this here. So I'm going to just model up the string as I did in my project, and I will show you that here in just a second after it's done. Okay, here we are. I have modeled up the string just as like I did previously. It is currently 1900 millimeters long. It has a slight bow right here to make it accurate to how a real bowstring will have a slight divot in the center. And after that, we can just hit done. And here we are. Here we have our string. Now we need to assign properties to it. To assign a property, you'll hit create, hit material. The name for the wood is called U. I'm just going to type in English wood. And then we're going to need some information about its elasticity. So go under mechanical elastic or elasticity, elastic. Young's modulus, this is going to be 15,700. Poisson's ratio, 0.3. Boom. Create the same thing for the string. And we're just going to go under mechanical elastic here. And I think the string was also 15,000.3. Great. So now we have the strings and the wood material. Now we have to assign a section. So we can just hit section here. For the bow, we're going to want a 3D. For the bow, we're going to want a solid homogeneous section because it is a 3D model. So we're going to call this Warbow section. And hit continue. And then for the material, we're going to select that to be the wood material that we have. We don't need to assign any plane thickness because it is a 3D shape. It's not 2D. And then we're going to do the same thing again, but for the string. The string, I'm considering it a beam element. So I am going to just type in string section beam and do beam. And then here it's going to get a little bit interesting. We're going to need to make a profile. So the profile is going to be a circular profile because strings are circular. So this is going to be called string circular. It's going to ask us for a radius. The radius for us is 1.25 millimeters. And boom, I completely misspelled circular, but you guys understand. Material type is going to be the string, and we're going to hit OK. Now we have to assign the sections for the materials. Since the string is here, we're going to assign it first. So what it'll do is it'll ask us to select the whole part. We'll select that. You can hit done, and then for the section, it's going to be the string section. It auto selected this, so this is nice. And when it's confirmed, it'll be blue like you see here. For the Warbow, this is what that looks like. We're going to also assign a section to this. Boom, Warbow section assigned. One other thing we need to do with the bow is that we need to partition it so that it actually, we can have a section in the middle that is constrained where your hand would be. I measured my hand, and roughly that is going to be 4 inches, which, or 3.5 inches, which is about 90 millimeters. So we're going to need to make a plane right in the middle of the part, which is the XZ plane here. If you hit 0, boom, you'll get your own defining plane here. We're going to use this defining plane to create some partitions. And we'll probably have to reassign some stuff, but that's okay. We'll use this defining plane to create some partitions. So we're going to do this again. I'm going to hit 45 because I know that's where the top of the hand will be. And we'll do negative 45. And that's where the bottom of the hand will be. So there's that. And we have created our planes. If you select this partition cell here button, you can see that there are other options. Anything with the dark arrow, with the black arrows in the corner, shows that there's another option. Here we're going to use partition cell. We want to do partition cell so that it cuts through the whole object and doesn't just create a sketch on the outside of the model. So it's asking us to select the datum plane. So we're going to select this datum plane here, create a partition, done. We'll do that again, select this datum plane. Oh, sorry. Here, because you've cut it, it's going to have different sections. So we need to just select the bottom section because that's the part that we're about to cut. Hit OK, and then select this datum plane, create a partition. If you go to View, Part Options, Datum, Show Datum Planes, and click that off, you can actually hide that. And we can see this little section here is where our hand will be. And this will come in very handy in the next step. All right, so in the assembly step, what we'll do is we will create an instance, which is this button. We'll have both of these guys added in. We're going to hit auto offset so that they don't interact with one another. And then we're going to hit OK. Great. So now I have the Warbow in the assembly, and we can now begin adding all of our loads and interactions. So let's go to step. We're just going to need to create one step for this. It's going to be a static general step. You can just hit OK. Afterwards, we're going to go to interactions, and we're going to need to create a special interaction. Go under create constraint, and this is going to be called an MPC constraint, which is a multi-point constraint. We're going to call this the top bow. What it's going to ask is going to select the multi-point constraint, so we're going to select that, and then it's going to select the second region. We're going to select this edge. We're going to hit done. Here, a little pop-up window will come up. We don't want it to be a beam. We want it to be a tie. All right, so we have the bow with its constraints applied just like that. What we're going to do now is we are going to actually translate the bow so that it's touching the string like it would be in real life. So the way you can do that is go to assembly, go to translate, select the instances to translate, which in this case is going to be the actual bow, and then select an axis for the start point. It's going to be the center here. And then the end point is going to be right here. So great. First things first, we're just going to be applying these loads in boundary conditions. So this first boundary condition is going to be called the hand grip. It's going to be a mechanical and then symmetric here. We are going to select this surface, hold shift, select this surface, hold shift and select this surface and hit done. We don't want this area of the bow to move at all in any directions while we're pulling the string. So we're going to use encastre right here and setting it all equal to 0. All right, so the next thing that we need to do is put the displacement on the actual string. And warbows are displaced roughly 500 millimeters. which is about 20 inches or so. So we need to put that displacement here. We're going to call that a boundary condition, and we're going to call this, and it's going to be under a displacement and rotation. And exact point that we want this is right here in the center on this node. The reason why I put a bend in this cable is so that I can get a center point right there. And we are going to hit OK. Now this point is only going to be in the X direction, so I'm going to hit -500. We're going to hit OK. We are going to do our last boundary condition. Done. So this is going to be called stop string. So we are going to do all of the directions that the string can't move besides U1, which is the X. We just now have to mesh the parts. The string, similarly, we're going to go to mesh element type. We're going to select the whole string, hit OK. We want to make sure it's a beam element, and we want to make sure that it's not quadratic. We want to make sure it's just B31. We're going to hit OK. We're going to hit seed. We're going to hit seed part. And here we don't need as many beam elements, but we do want some. So I'm going to hit 5. And that'll put a ton right there. And then we're going to hit mesh part. Yes. And if you see a blue line or blue configuration, it means that the part is properly meshed. All right, so here's a bow, and we're going to mesh the bow now. We are going to need to add nodes to this. The way that I do this is go to seed, and I actually usually check what type of element that we're going to be applying. What we want to apply is a standard 3D stress hex C3D8R. We're going to go to seed and then the part, and we're going to do some number like 2. Hit apply, delete meshes, OK. Go back to mesh, mesh the part. Go back to the assembly, tools, query, mesh. Great, 130,000. I remember in my model I needed to get it above 100,000 for this to work. Great, so now everything is meshed, everything is good. The last thing to do, I always forget this, beam section orientation, select the string, hit done, hit OK on whatever the defaults are, and hit OK here. Hit job, we're gonna call this bow pull back, hit OK. You'll see this, submit the job, and now we wait. Go to results, and we'll have our undeflected beam. If you hit this button, you can show the undeflected and the deflected beam, and we can see that it really deflected a lot. But there's also a deflection factor here, so it's actually not showing how much it really deflects. The way that we can change that is go to options, common, go to deformation scale factor, go to uniform, make sure this is 1. If we go and click on Z, you can see the whole Z factor, and you can see from the first point to where it deflected quite a bit, right? As you can see, and it's super dark here. And this is the area of the stress where there isn't any stresses. If we go up to here and go up to reaction forces and click RF1, we can see these are the areas where the reaction forces were happening. So we know that thanks to Newton's law, every force has an equal and opposite reaction. So if we probe the nodes and we go to the specific point where we had put our pullback, we'll get this value for RF, and we should be seeing that value right here, but we aren't. We're actually seeing a value that's much lower. So the way to get this is to actually go up to reports, field output. We're going to go to unique nodal, go to RF, and it's because we need to see what the RF in the X direction is. We're going to hit RF1. We're going to hit apply. And what that'll do is that'll come down and create an abacus file and call it a report here. Created the report here. We'll have to go to the start menu, click temp, and type in exactly this, C:\temp. That'll bring us to our temp folder, which is where a lot of the abacus files are going to be saved. And if we change this to date modified, we'll see our abacus file right here. We will right click, open with Notepad. And this will show us the report in this whole area, just the Warbow, all the way to the, we will see that it is in fact the exact same. And so, yeah, that is our reaction force 875.